Welcome back guys to another episode of Physics Tutorial. So today in this video we are going to be finding the minimum energy required to lift a 1.7 times 10 to the power of 3 kilogram vehicle from the surface of the moon to a height of 5.22 times 10 to the power of 6 meters. So as you can see, I've drawn a diagram here, and we're going to be trying to lift the vehicle from this point to this point up here. Now we are told the height, and it's important to remember that the height is only this height, not the height to the center of the moon, which is entirely different. So in order to solve this problem, we are going to be finding the minimum energy, which means that the minimum energy, I'll just put T for total, is equal to the potential energy at the top point, which I'll put as EP2, subtract the potential energy at the bottom point. Because as you can see, when the two objects are stationary and at a certain height, there's no kinetic energy, there's only potential energy. So that's how we're going to find it. And of course, the formula for potential energy is equal to negative g, mass of the moon, mass of the object, divided by radius. So you should know from your datasheet that the radius of the moon is 1.74 times 10 to the power 6 meters. And that the mass of the moon, I'll just do that here, the mass of the moon is equal to 7.35 times 10 to the power of 22 kilograms. So now all we have to do is solve it. So I'm going to solve for EP1 first because that's easier. And EP1 is of course the potential energy at the bottom, which is the surface of the moon. So EP1 equals negative g, and g, you should know, is the gravitational constant, which is 6.67 times 10 to the power of negative 11 multiplied by the mass of the moon multiplied by the mass of the object, which you can see here is 1.7 times 10 to the power of 3 kg. Power 3, sorry. And then divide all of that by the radius, which in this case is only the radius of the moon. It does not include this radius yet. So divide by 1.74 times 10 to the power of 6. So when you calculate all of this, the EP1 you get should be negative 4.8 times 10 to the power of 9 joules. And once you've found EP1, you also have to find EP2. Now EP2 will be a bit more complicated because you have to EP2 because you also have to find the height, which is, you have to find the new radius, which is 5.22 times 10 to the power 6 added to the radius of the moon, which is 1.74 times 10 to the power of 6. So you should add this up, and the value you should get is 6, 8. But other than that, it's pretty much the same thing, because what you have to do is now you just do all of this. Negative 6.67 times 10 to the power of negative 11 times 10 to the power of 22 and 1.7 times 10 to the power of 3. Divide all of that by this value and you should get negative 1.2 times 10 to the power of 9. And now all you have to do is subtract the two from each other. So the total energy needed is equal to negative 1.2 times 10 to the power of 9, subtract negative 4.8 times 10 to the power of 9. And the final answer that you get should be 3.6 times 10 to the power of 9 joules. And this is the minimum energy needed to lift a 1.7 times 10 to the power of 3 kilogram vehicle from the surface of the moon to the height of 5.22 times 10 to the power of 6 meters. Now you have to be careful that when you're calculating it, the value here you have to subtract by negative. And the reason potential energy is negative is because we actually, to make calculations easier, we set, so imagine a distance between two objects, and the distance is infinity. So at infinity, the two objects are not related at all, and that means that there's no potential energy, which means that at infinity, the potential energy is 0. But we are not at infinity, we are very close to the moon, which means that it has to be negative because we add potential energy to reach 0. So that means that we have to continuously add energy for it to reach infinity. But we are not at infinity, which means that the potential energy here is negative. And yeah, so that is how you solve this problem. Subscribe for more, I guess. I won't make any more of these, but, subscribe.